Let's take a look at this example. In order to find Z total, we're supposed to find the impedance of the capacitor C1 and we're supposed to find the impedance of the inductor L1. So we have formula Z sub C. Okay, because I have just one capacitor, I'm not going to write Z sub C1, I'm going to just write Z sub C is equal 1 over 2 pi FC. Okay, we can say FC1. So we have 1 divided by, open parenthesis, 2 pi times F, which is equal 60 Hertz, times capacitance, which is equal 47 microfarads. This is equal, I'm going to use the calculator to find the value of Z sub C. So I have 1 divided by, open parenthesis, 2 pi times 60 times 47 exponent 6 negative, close parenthesis. This is equal 56.43 ohms. 56 and 43 ohms and angle of negative 90 degrees. Remember that anytime we calculate the impedance of the capacitor, we're supposed to add angle of negative 90 degrees, or we can simply write that this is negative J 56.43 ohms. Okay, so this is polar form, this is rectangular form. Next, we're supposed to find ZL. The formula says ZL is equal to 2 pi FL. In our case, this is L1. So this is equal 2 pi times the frequency, 60 Hertz, times inductance. So I have 390 millihenries. So ZL is equal 2 pi times 60 times 390 exponent 3 negative. This is equal 147.02 ohms and angle of 90 degrees, or we can say this is equal J 147.02 ohms. Okay, so this is the impedance of my inductor. Next, in order to find Z total, we're supposed to realize that these two components are in series. So I'm going to find I'm going to call it Z1. Okay, I'm going to combine these two components together. I'm going to add these two impedances. So I have formula Z1 is equal R1 plus ZL. Okay, you can call this also ZL1. This is equal, R1 is 100 ohms plus ZL is equal 147.02 ohms and angle of 90 degrees. This is equal, I'm going to use the calculator, so I have 100 plus 147.02 and angle of 90 degrees. This is equal 177.8 ohms and angle of 55.77 degrees. This is the impedance of these two components connected in series. Next, we can redraw the diagram to see how everything got changed. So I have capacitor and I have my Z1 over here. Okay, and I have also resistor R2 over here. So as you can see that these two branches are in parallel. So I'm going to use the formula for the parallel circuit. So I'm going to call this Z2. Okay, so my Z2 is equal Z1 times R2 over Z1 plus R2. So this is equal Z1 177.8 ohms and angle of 55.77 degrees times R2, which is equal 100 ohms, divide by, open parenthesis, 177.8 ohms and angle of 55.77 degrees plus 100 ohms. This is equal, so Z2, I'm going to use the calculator. So I have 177.8 angle of 55.77 times 100 divided by, open parenthesis, 177.8 angle of 55.77 plus 100, close parenthesis. This is equal 71.62 ohms. So this is equal 71.62 ohms and angle of 19.45 degrees. 19.45 degrees. So we have Z2. Now we can redraw the circuit one more time. So take a look what we are going to have. We have voltage source, we have capacitor, and we have Z2. Now you can see that we have series circuit. So if you want to find Z total, simply add these two impedances together. So Z total is equal Z sub C plus Z2. This is equal, Z sub C was equal 56.43 ohms. So we have 56.43 ohms and angle of negative 90 degrees plus Z2, which is equal 71.62 ohms and angle of 19.45 degrees. Now I'm going to use the calculator and I have 56.43 angle of 90 negative plus 71.62 angle of 19.45. This is equal 74.98, so I have 74.98 ohms and angle negative 25.75 degrees. Okay, so this is the value of Z total. Next, the problem is asking me to find I total. in order to find I total, I'm supposed to use Ohm's law and simply write that I total is equal voltage source over Z total, where voltage source is equal 115 volts. So I have 115 volts RMS over Z total, which is equal 74.98 ohms and angle of negative 25.75 degrees. Okay, this is equal, I have 115 divided by 74.98 and angle of 25.75 negative. This is equal 1.53 amps and angle of 25.75 degrees. So this is value of my I total. Next, we're supposed to find the voltage across the capacitor. Okay, I have to find V sub C. So please notice that the total current is going directly to the capacitor. So I can say that I total is equal to IC. Okay, and this is equal 1.53 amps and angle of 25.75 degrees. Okay, so V sub C is equal IC times ZC. So I have 1.53 amps and angle of 25.75 degrees times Z sub C. We found this is equal 56.43 ohms and angle of negative 90 degrees. So VC is equal, we have 1.53 and angle of 25.75 times 56.43 and angle of negative 90 is equal 86.33 and angle of negative 64.25. Okay, so let me write it down. So VC is equal 86.33 volts and angle of negative 64.25 degrees. Okay, so this is my VC. Next, I'm supposed to find the current which goes through the resistor R2. Okay, so what I'm supposed to do next? I'm supposed to realize that if I'm going to find the voltage across Z2, I'm going to have voltage across the resistor R2 because these three components connected together represent my Z2. So voltage between these 2 points is the voltage across my Z1 and also voltage across resistor R2. That's why I'm going to find the voltage across Z2. This time I'm going to use voltage division law. Okay, so I have V Z2 is equal to VZ1, okay, I want you to realize that, and this is also equal to VR2. One more time. Z2 is the total impedance of these three components. So if I'm going to find the voltage between these 2 points. This is the voltage across Z2, or this is also voltage across Z1, or this is also voltage across resistor R2. So this is equal voltage source times Z2 over Z total, where voltage source is equal 115 volts. I want you to realize that anytime I'm using the voltage RMS and I'm looking for current, I'm going to obtain the RMS current. And let's say if I'm looking for VZ1 or VR2 or VZ2, the voltage is going to be also RMS. So I have Z2 we found is equal 71.62 ohms and 19.45 degrees. So I have 71.62 ohms and angle of 19.45 degrees divided by Z total, and Z total is equal 74.98 ohms and angle of negative 25.75 degrees. This is equal let me use the calculator. So I have 115 times 71.62 and angle of 19.45 divided by 74.98 and angle of 25.75 negative. This is equal 109.84 and angle of 45.2 degrees. Okay, so this is volts, and angle of 45.2 degrees. Okay, so this is voltage across resistor R2. Now we can find the current which goes through this resistor. We are going to use Ohm's law. So I'm going to continue over here. So I R2 is equal VR2 over R2. So this is equal VR2 109.84 volts and angle of 45.2 degrees divided by R2 100 ohms. So IR2 is equal 1.09 amps and angle of 45.2 degrees. Okay, so this is my current which goes through the resistor R2. Next, we're supposed to find the voltage at the inductor L1. Okay, so let me remind you that we found VZ1 equal 109.84 volts and an angle of 45.2 degrees. So this is the voltage between these 2 points. Okay, so we have to find this voltage. In order to find the voltage across the inductor, I'm going to use again voltage division law. Okay, and let me show you how it's going to look like. So I'm going to have VL is equal VZ1 times ZL over Z1. Okay, because these two components are in series. Okay, so they're going to divide my voltage. So I found this voltage, voltage between these 2 points. Voltage between these 2 points multiplied by the impedance of the inductor divided by the total impedance of this branch will give me voltage across the inductor. So let me plug in the values. So VZ1, as I said, we found is equal 109.84 volts, an angle of 45.2 degrees, times ZL, which is equal 147.02 ohms, an angle of 90 degrees, over Z1, which is equal 177.8 ohms, an angle of 55.77 degrees. So I have VL equals 109.84 angle of 45.2 times 147.02 angle of 90 divided by 177.8 angle of 55.77. This is equal 90.82 volts and angle of 79.43 degrees. Okay, so let me write this down. This is equal 90.82 volts and angle of 79.43 degrees. This is my VL. And now I can say that the problem is solved.